So welcome to the Prometheus Deep Dive of KubeCon. My name's Ben. I'm a site reliability engineer at GitLab, and I'm also been a contributor to the Prometheus team for quite a number of years now. Most of my work is not on Prometheus itself, but all of the exporters and integrations that people use. And yeah, feel free, if you have questions, one of our other Prometheus developers will be handing out mics during, if you have a question in the middle of the talk, feel free to interrupt me. I don't mind. Quick 101, since this is the deep dive, but you know, Prometheus started in late 2012. It was created as a it was created to solve real-world problems. We had quite a lot of metrics, but we also had problems with having monitoring at the time, Nagios, keep up with the rate of change in our infrastructure. And so we built this system to be an active monitoring system and not just a passive data collector. Who went to the intro yesterday? Yeah. Maybe another random audience question. Who's already using Prometheus? Woo! Who's not using Prometheus and is just getting started? Yeah, cool. So now that you've got Prometheus installed, what do we do here? Well, there's a lot of good reading material on monitoring itself and why it's good to use monitoring to let you know when your systems are working properly. I'm a big fan of the read method and use method. They're kind of two sides of the same coin, and it's all about looking at your metrics from the perspective of your users, because your users don't care if you're out of memory or your CPUs are overloaded. They care if their requests are going through and they're going through quickly. And there's a lot of great material on that. And then for Prometheus itself, there's a couple of really great books that you can read. They go through all the detail of getting you into Prometheus. But yeah, so Prometheus itself is what I call an intentionally uncoordinated distributed system. Is the Prometheus design came from a need where the monitoring system needed to be the most reliable thing on the network, and which meant that the Prometheus itself needed to have the least number of dependencies on anything else on your network. So as long as it's up and running, it's got a little local disk, and it can reach to the network, it can monitor it. Versus other monitoring platforms where, like, if your link to the internet goes down, you lose all visibility because you can't send any data to your SaaS platform anymore. If Prometheus included monitoring that included a distributed storage cluster, well, how can you monitor if when your Cassandra is down? You know, you want Prometheus to be able to tell you that your Cassandra is down, or whatever you happen to be using for storage. You want to run Prometheus close to your targets because you don't want to monitor your WAN links or other network as a side effect of your target monitoring. And we always recommend that you think about vertical sharding before you start thinking about horizontal sharding. So if you've got 1,000 pods and 500 of them are for one service and 500 are for another service, split your Prometheus to have 500 to one service and 500 on the other. And yeah, so it's a minimal dependency, super robust piece of software. The Prometheus includes its own built-in time series database. It uses write-ahead log for reliability during operation and restarts. But the time series database itself is written out and is immutable, so it's hard to corrupt, and it works pretty well. It goes through simple compaction cycles to make the indexing more efficient, and it's just designed to be reasonably simple and robust. So yeah, there's a lot of common questions that I get for Prometheus. Prometheus is collecting float64 data all the time, and the best practice is you want to expose you want to count your events and expose those as counters, because because Prometheus is a polling-based system, if you lose a data point, you don't want to lose the information that was contained in that data point completely. So you have a count of, say, 1, and then a scrape happens, and now the count is 2, and another scrape happens, and now the count is 3, and oops, you missed a scrape, and you come up, and the next count is 5. So you don't know whether it went from the next scrape would have been 3 or 4, but at least you know that the total is still there. So you don't actually lose you lose fidelity, but you don't lose accuracy. And so because of this, the first thing that you tend to run on a Prometheus counter is you run a rate or an increase to find out what the rate of change of that counter is, because most of the time, if you're counting CPU seconds to find out how much CPU usage is going on in a process or a server, you need to take a rate to find out how many CPU seconds per second is being used. And that gives you, the percentage of CPU utilization, or how many cores a process is using if you've got a multi-threaded app. And so here's some real-world example of data points. And so this is 60 seconds of data for a counter that's going up in somewhere around, 1,500 to or so every 15 seconds. And you can see that the scrape interval is 15 seconds. So we get 4 data points within 16 seconds. And there's like one at 4 seconds, a next one at 19 seconds, et cetera, et cetera. And then that's just one instance of this server. So we've got this is from a HA proxy web server, or web reverse proxy. And we, of course, have more than one HA proxy to load balance all of our systems. So here's the data points from a different HA proxy. And so it's not going up as fast, but also notice that the samples are offset differently. So Prometheus, you tell it to scrape all of your targets every 15 seconds, and it's not doing that on a clock basis. It's actually taking all of your targets and spreading them out over the scrape interval so that you get this nice even flow of ingestion into Prometheus. It also gives you some nice mathematical effects to get more accurate information. And so when you get a bunch of different data points, you can see that they're spread out all over time within that window. And now we want to query this, and we want to get a rate. So we're going to say I hit the query button, and I time aligned my query so that my query time is at the top of the minute. And I'm asking for an increase over 30 seconds. And so now I've got 2 data points that fall within that 30-second window. And what Prometheus does is, instead of giving you the difference between the first data point and the second data point, it actually extrapolates the 2 data points to find out what the total increase would be if there were more samples within that section, or within that range. And this is really a little bit confusing for some people, because they see a counter and it goes up by 1, and they're like, but I got a number that I got 2.5 and they're like, that's confusing. And well, it's all because of this interpolation, because you ask Prometheus for 30 seconds worth of increase, but it's only got data points that are 15 seconds apart within that time window. So it has to extrapolate to give you the correct answer, because if you note that counter is kind of going up at the same rate. And once we start adding more data points back into this, and we do more extrapolation, you can see that it is now going to work out, because now if I want to take all 4 of my HA proxy servers and sum up that increase, I can now not have to worry about the milliseconds of difference in time between the different scrapes that are in that time window. Another interesting thing is, what if I asked for a minute of increase? I don't have any more pretty pictures. Thank you, GNU-plot. What if I asked for an increase, and what if over the whole minute, what if say that the blue circles on the top of the graph, the first 2 data points were missing. So if I didn't do extrapolation and I was missing those 2 data points, I would only get a say, about 2,000 on the increase versus the total of 6,000, which is what is really going on here. So it's one of those cases where we do the interpolation, we do the extrapolation of the data in order to try and produce a more accurate overall picture of the data that you've got in your metrics. So next big question a lot of people ask is, okay, so now I've got a Prometheus and it's overloaded, or I started and I now have 2 Prometheus servers and I've got high availability, and we're going to start talking about scaling. And the first question people ask is, well, how do I capacity plan? Well, it depends mostly on the rate of ingestion of your data, because as Prometheus collects data, it's got to store it somewhere, and it needs currently about 1.5 bytes per sample, and so it's pretty easy to just do a little bit of capacity planning math, and it also depends a little bit on the data that you've got. So usually the recommendation is you start out, you look at you scrape some of your data, and then you can now start to build a capacity planning story for your Prometheus, and so like, for example, we have a server in our production environment that's doing about 100,000 samples per second by about 1.5 bytes for 60 seconds for 60 minutes, and it's about half a gigabyte an hour. And that's a bit of data, but it's not too bad. And 100,000 samples per second is quite big. We have a lot of metrics and a lot of data, and that's just one of our Prometheus servers. Now the question is now I've got all these multiple instances, and how do I scale it? Well, there's a bunch of different ways. Prometheus has a technique called federation, where you can take a single Prometheus that is collecting data from a lot of targets, and you don't maybe not even care because it's say a bunch of individual auto-scaled pods, and the individual pods don't matter. So what you really care about is the cluster level data. So you have what Prometheus uses called recording rules, where it takes a Prometheus query and stores that into a new metric. And then you can have a federation server on top of that that pulls in just the recording rules and ignores the individual pod data. And that's a simple, like, hierarchical system. The problem is, of course, if you tried to pull everything into that federated server, it would blow up, because if you try, it's not a method of like replicating. It's a method of tiering. But if you really want to get all of the data into a database, well, you're going to need some kind of horizontally scalable database. And in the Prometheus design, we have the individual Prometheus servers that are small and robust and good for alerting, and then you've got these large-scale databases that might fall over if there's a network partition, but at least the alerting is still going to work. And so things like Cortex and M3DB and Thanos are different methods of doing horizontal scaling of the data from multiple clusters and multiple instances of Prometheus, and dealing with the high availability deduplication and things like that. And for a long time, we've had this service discovery moratorium. And we're finally out. We're now taking new service discovery methods. So who here is using Docker Swarm and would love to have Prometheus support for Docker Swarm directly? Well, we can do it now. Somebody open a pull request. And yeah, I want to save time because lots of people have questions. So let's do Q&A. Bjorn, do you have a question? What's your biggest problem with Prometheus?
No comment. Okay, we have
one here.
Go first.
What is the impact in storage of using many labels per metric?
Sorry, say that again?
What is the impact in terms of the storage when you use many labels per metric?
I'm not sure.
Storage.
What's the impact on the storage?
How much more space do you use for a metric if you're using many labels?
So yeah, the Prometheus uses an inverted index. So when you add a new label, it doesn't really take up that much more space, because the index itself only really needs to store the key from that label into the metric. And it's relatively efficient, so it's totally okay to have a bunch of different labels, especially if they're important. You want them to you want to be able to have your infrastructure, like if you're talking about like service discovery labels, and you've got maybe a data center label or a cluster label, and like those are not that expensive.
Perhaps mention the cardinality issue, the infamous.
Yeah, you want to make sure that you don't have tons of values for those labels, because the more values, the bigger the index is, and the longer it takes to scan those indexes when you're walking a metric. But if you've got tens of data centers or hundreds of clusters, that's a reasonable amount of cardinality.
It's also how things are correlated. So if you have an instance label naturally, and then you add a cluster label, but in one cluster you always have the same instances, it's actually not increasing cardinality. That's essentially a free label. But if you add something completely orthogonal, you get those like square growth of cardinality. Okay.
So regarding pre-aggregates, let's say I capture a metric for a month. Does Prometheus supports creating a new pre-ag after a month and then pre-aggregating on existing data, or does the pre-aggregate has to exist at the time that the metric is getting captured? Does that make sense?
Should I take it?
Sure, why not?
I mean, that sounds like retroactively evaluating recording rules. Is that it? Yeah, okay, that's not yet a feature, but the plumbing is all in place. So it's on the roadmap, and it will, I don't know, whoever works on it. It's actually pretty straightforward technically now to do.
There's actually an open pull request to start building into PromTool some of that ability.
So the TSDB is structured in a way that inserting individual time series later is a really expensive operation. But there is, like, it's implemented as an operation, and now you just need the tooling that reevaluates a rule or that backfills data you got from another source, and this will all happen fairly soon. Okay, more there?
I've got one. I got it.
Yeah, you go.
That one first.
Okay, sure. Yeah. Thank you. I'm curious what experience you have with the aggregation layer. Your Thanos, your Thanos Cortex. What kind of experience do you guys?
Yeah, so at GitLab we're using Thanos because it was really, really nice to deploy. Before we were using Thanos, we were smaller and we were growing and we were adding more Prometheus servers and we were having more, it was tedious to set up dashboards that pulled from multiple, so we're using Grafana for our dashboards, and it was tedious to have like one data source for this cluster and this data source for this cluster, and mixing data sources was really annoying. So we added Thanos as an overlay proxy to make it easier to query. But we weren't actually using any storage. So we actually had 6 months of data in our Prometheus servers, and that was working quite well. And it was just, Thanos was an add-on to start doing the overlay layer and deduplication, because we had between our Grafana and our Prometheus servers, we had a little Nginx failover. So it's just whichever one was, it would pick the first one, and if that one was down, it would grab the second. I forget what the Nginx config is for that, but it was just a simple failover. And then, but that would produce weirdness sometimes because, of course, they've got different gaps. And so adding Thanos to do the gap fill was really, really nice. And then after we rolled that out, then we started to experiment with pushing our TSDB data into object storage and using the Thanos storage for that.
So yeah, quick follow-up.
Oh.
Can you hear me?
Yeah.
Quick follow-up then. Did you guys use any sort of caching layers? Because the Thanos queries can get kind of slow.
Yeah. So we're using we're using it for our public dashboard. So we're using Trickster, and it works okay. But yeah, there's a bunch of I've been talking with the Thanos developers, and we're talking about adding a caching layer. And actually, specifically, there's talk about bringing the Cortex query caching layer into Thanos. And so like there's some code share between all these projects. Like that's the nice thing is we've got a good team where the Cortex developers and the Thanos developers and the Prometheus developers are all kind of the same team, and it's just slightly different techniques for the same stuff.
I think that's already merged. Like you can use this Cortex cache for normal Prometheus for Thanos. It works in all directions.
Cool.
So Prometheus Alert Manager is like a nice tool for monitoring alerts and such, and I like its simplicity. But do you have any other integrations that might like empower like the ops personnel that's collecting Prometheus data to like tune their alerts without necessarily having to go into like create configurations at the code level or like PromQL and such?
Like GUI tools for the alerting rules. We keep trying to convince the Grafana people to build that for us. But no, I don't. Most of us on the Prometheus team we're back-end developers. We don't like doing UI.
I got one over here.
Yeah. Do you have any recommendations or resources on how to like go about comparing, contrasting the various storage solutions between Cortex, M3DB, or Thanos, and how to choose one to use for your environment?
Not specific. I don't have any. Björn, do you have any recommendations for picking a storage layer? It depends on what your like network layout is, and you know what your what kind of storage systems do you have? You know, depending on how much complication do you want. Like the Thanos is really interesting because it only requires object storage, and it works really well if you have like integrated network where you can actually have Thanos query talk directly to the Prometheus servers. But if you're very highly distributed and you don't have a global VPN and you've got remote sites, something like Cortex might be better, where you've got the remote Prometheus servers behind some kind of NAT, and it streams the data out to the internet over the public internet and sends it up into a Cortex service.
So you asked us what's our greatest problem with Prometheus right now. For us, it's that the Jenkins plugin doesn't work. We installed it and it crashed immediately. Now, before I go fix that and submit a PR for myself to fix it, what is the plan for things like Jenkins or other integrations that are popular but might not be in the core of what you guys are working on?
Yeah, no, we actually have a separate GitHub organization called Prometheus Community, and we're slowly trying to build that up as like the place where popular things can go and have additional maintenance and be more official than just some random other GitHub org. And we're slowly trying to get that on board. And so check out the Prometheus Community GitHub org.
I'll do that.
Maybe this is a little more starter question. We've been using Prometheus prom operators and getting our all the metrics for our cluster, and that's working really well. We've got Grafana running, all sorts of interesting dashboards. And as soon as we do that now, the application developers are saying, hey, I want to use that for some application-specific metrics that we want to put in. And I'm wondering if you could talk a little bit about what we have to do that. I know there's SDKs for Java, Go, Node, whatever, but now are we running an additional web server that's going to be on each one of our pods that are now hosting all the metrics? Are we sending them somewhere? Are we registering with that? I mean, the POM operators were great for the cluster, but now to actually build this in, how complicated is that going to be?
Yeah, so all of the Prometheus metrics protocol is simple HTTP GET, and all of the Prometheus client libraries include hooks into whatever language web servers are available. So if you've got the Java, it uses the Java web HTTP server. You have a Golang, it uses Go HTTP. So you just use these Prometheus client libraries in your code, and either on an you can register it if you've got like a request router. You can register. You can put the Prometheus metrics registry, which is the usual name for the internal metric counter trackers, and you can just send a route to /metrics, and Prometheus can then scrape that data and collect and put it into the database. But there are cases where you might want to put it on a different port and set the service discovery so that you've got your main API port and you've got your metrics port. But it's kind of up to, it depends on the language and things. Like we actually recently moved. We have a large Rails app, and we're moving the Prometheus metrics from an inline controller to its own dedicated port on the Unicorn controller process. So because it turns out that whenever we get slammed with traffic, Unicorn queues, and then we lose monitoring. And so we've moved it to a separate port because of the limitations of Ruby. But on Golang, it's all Go routines, and it's no big deal. Got one on the right.
Can you give us an update on the state of vertical compaction in Prometheus?
Like what specific question about compaction?
So if you're backfilling data from a different Prometheus server, if you're like doing a remote write, or if you have Thanos and you have HA pairs that are both providing data for the same time period, kind of compacting that down so that you're not keeping the duplicated data in object store?
That's more of a question for things like Cortex and Thanos. I believe Cortex takes the HA and throws away one of them automatically, whereas Thanos keeps both and keeps both around. And so that's kind of like Prometheus. Prometheus itself is not a remote write receiver, so you can't stream one Prometheus to another. That's more of a question for things like Thanos and Cortex.
Yeah, so both of them have deduplication logic, and if you backfill into a Prometheus server with this tooling we mentioned, which is kind of there but not really readily available, then it will not do deduplication. It will just put it all together into one time series block.
So I understand that most people are using Grafana to visualize Prometheus now. Has there been discussion about a way to quickly visualize all the metric graphs of a target in Prometheus itself?
So yeah, the Prometheus web interface is intentionally simple, and it's mostly there to like provide a basic debugging interface and getting started and testing queries. And then my usual workflow is I'll be on Prometheus or Thanos user interface, and I'll do a bunch of test queries, and I'll figure out what I want. And then I'll copy and paste those into Grafana. But we actually just started a rewrite of the web interface. The original web interface on Prometheus was handwritten JavaScript, and it was really annoying to work on. And we've got a new UI we're rebuilding in React. So we're looking for more contributors to contribute features to the built-in Prometheus UI.
There's also work on an LSP implementation for PromQL that this React UI could perhaps use, or you can use in VS Code. So it's quite exciting what's happening there.
This might be a GitHub issue, but I'm going to ask it anyways. Is there going to be any continued support for sizing on TSDB being specified on the CLI? It's an experimental feature right now, and it does not work properly for me.
You mean the TSDB size-based retention?
Yes, correct.
I haven't heard anything that it doesn't work. I've tested it. It works for normally.
Okay.
So
GitHub issue.
Yeah, sounds like you might have hit a bug. Anybody else got one right here?
I wonder if you have any tips or anything for config management, because config management in Prometheus can get heavy. It has a lot of configs, alert configs, and you also have to often update configs all the time. You want to add an alert or to remove an alert. So
yeah, depends on what you're your configuration management system is like, we have a lot of our configuration in Chef. Other people are, there's the operator stuff, and you can use
JSON it.
JSON it. Yeah, there's a lot of JSON is super interesting. We're actually moving all of our dashboards into Grafana JSON it. So instead of hand clicking and making all of our dashboards, we auto-generate them so they're all consistent with all the services.
So Prometheus is super opinionated in many aspects, but this is intentionally up to you to pick your own poison. Having said that, a bunch of projects get mix-in subdirectories, just as examples how you could, with JSON, create rules, create dashboards. But that's not as in like, this is not one canonical way, it's just a way for us to document possible rules, possible dashboards. We have a few more minutes.
So as like an infrastructure or operations person, I think Prometheus makes a lot of sense, and the scalability aspect of it, it's very logical. There's a bit of an overhead, I think, when you ask sort of regular day-to-day application engineers to start using it, because there are some sort of non-intuitive concepts in there. They're like different than a metrics as a service kind of company. Do you have any recommendations on sort of like how to onboard people mentally into Prometheus?
The Prometheus books, and we have a bunch of how-to guides and tutorial stuff on our website. We're always looking to improve those, and yeah, we also have a YouTube channel. So every year we have a Prometheus conference, and we have lots of great talks. And I'm actually going to be putting together, after we get the 2019 talks posted online, I'm going to make like a Prometheus 101 playlist on YouTube.
Cool.
And I think that's all we have time for.